Welcome to aminacademy.com. In questions, how, why, and what. In that, let us ask some questions. What is the time dilation? What is twin paradox? An object moves with relativistic speed. A strange thing seems to happen to its time as observed by us, the stationary observer. That means we are in the earth. What we see happen is that the clock in motion slows down according to our clock. Therefore, we read two different times. Which time is correct? Well, they both are correct because the time is not absolute but it is relative. It depends on the reference frame. That means how it's moved from the fixed point. Let's look at the following classic example. There is a set of twins, one on astronaut and other works of mission control in NASA. The astronaut lives on a deep space ship traveling at 95% the light of speed. Upon it's not really possible, but it's a paradox. 95% the speed of the light. Upon returning, the astronaut's clock has measured 10 years, so the astronaut has aged 10 years. However, when the astronaut reunites with his Earth-bound twin, the astronaut sees that the twin has aged 32 years. This is explained due to the fact that the astronaut's twin is traveling at relativistic speed and therefore his clock is slowed down. Let's see how we can calculate the time difference. The equation for calculating time difference, everything is there. Now let us discuss further detail about what is the time dilation. Yes, time dilation, a phenomenon predicted by Einstein's theory of relativity, is real and has been confirmed by experiments. It means that time passes differently for observer in different frames of references, particularly when they are moving at high speeds or in strong gravitational field. Time dilation explained. The time dilation occurs because the time is not an absolute but rather relative to the observer's motion and gravitational potential. Relativistic time dilation. As an astronomical object moves faster relative to a stationary observer, time passes slower for the moving object according to the stationary observer. This effect becomes noticeable at speeds approaching the speed of light. Gravitational time dilation. Time also passes slower in stronger gravitational fields. That means time also passes slower in stronger gravitational fields means if suppose our Earth's gravity is increased, then our time will be slower. Object closer to a massive object experiences time dilation compared to those farther away. Experimental evidence. Atomic clock. Experiments comparing atomic clocks at different altitudes and thus different gravitational potentials have demonstrated gravitational time dilation also. Muons. The increased lifetime of unstable elementary particles, muons, traveling at nearly the speed of light as predicted by special relativity is another example of the time dilation. GPS satellites. GPS satellites need to account for time dilation effects, both relativistic and gravitational, to maintain accurate positioning. Practical implications. While time dilation effects are usually negligible in everyday life, they become significant in space travel and other applications involving high speed or strong gravitational fields. Some example, an astronaut on the International Space Station in ISS orbiting Earth at a speed of about 7,700 meters per second would experience a very small amount of time dilation compared to someone on Earth. Time and gravity are twins. The phrase time and gravity are twins refers to the concept of gravitational time dilation, where time passes slower in a stronger gravitational field as predicted by Einstein's theory of general relativity. Time dilation is the phenomenon where time passes at different rates for different observers depending on their relative motion or position in a gravitational field. Gravitational time dilation. This specific type of time dilation occurs because of the presence of gravity. Clock tick slower in region of higher gravitational potential closer to massive object compared to region of lower gravitational potential farther from massive objects. Einstein's theory of relativity. Albert Einstein's theory of general relativity, which describes a gravity as the curvature of space-time, predicts that time is relative and can be affected by gravity. Experimental verification. Gravitational time dilation has been experimentally verified through various tests, including comparing atomic clock at different altitudes and observing the gravitational redshift of light. Twin paradox. The twin paradox is a thought experiment that highlights the effect of time dilation if one twin travels at high speed through space while the other remains on Earth. The traveling twin would each move slower than the twin who stayed on Earth. Practical implication. Time dilation has practical implications such as the need to account for it in the GPS satellite navigation system, where the high speed and altitude of the satellites cause a slight difference in timekeeping compared to clock on Earth. So far, we discussed about some interesting things about time dilation and about twin paradox. We have done. Please subscribe our YouTube channel.